Hi friends, in this video, our topic is voltage drops in alternator. In generally, for example, this is my alternator diagram. This is the supply voltage V, and this is total resistance and total reactance. And here the current is I. Sorry, this is induced EMF E. And this is the load voltage V. Load voltage V. Then what is the equation here? E is equals to V plus IAZS. V plus IAZS, armature resistance, synchronous reactance, and synchronous impedance. This combinedly called as synchronous impedance. So E is equals to V plus IAZS. How we can utilize this one? V plus IAZS बोले तो RA plus JXS. XS क्या है? XS nothing but synchronous reactance. Very good. So here E is equals to V plus IARA plus J of IAXS. XS can be written as XA plus XL. XA is nothing but armature reactance, fictitious reactance. XL nothing but leakage reactance. Now the EMF E is equals to V plus IARA plus J of IAXL plus J of IAXA. But I want the load voltage. So tell me, what is load voltage? V is equals to E minus IARA minus J of IAXL minus J of IAXA. This is the load voltage. For example, the full load voltage 200 volts, the generated voltage 200 volts. For example, this is 1 volt and this is around 10 volts and this is around 15 volts. So 1, 10, 15, around 26 volts is minus from this one. So the full load voltage is 200 minus 26. Nothing but some voltage is dropped here. How much voltage dropped here? Here the voltage drop is due to one is the armature resistance and other one is the leakage reactance and other one is the armature reactance. These are the three factors for voltage drop in our synchronous machine. Actually, out of total drop, the drop due to armature resistance is just 1% only, very less, negligibly small. But the drop due to leakage reactance is around 15%. This is around 15% of drop. Nothing but this is 0.01 per unit drop, this is 0.15 per unit drop. The remaining drop is due to armature reaction or armature reactance, 84% of drop. Nothing but this is 0.84 per unit. Now tell me, in synchronous machine mainly drop due to armature reactance or armature reaction. Drop due to nothing but all of the above. Mainly drop due to nothing but option C. Negligible drop due to option A, option B, option C, option D, all of the above. They're given like that. So option A, negligible drop. Option C, mainly drop. Option D, all of the above. Drop due to all of the above. Mainly drop due to this one. Negligible drop due to this one. This is the voltage drops in our synchronous machine. So let's draw the vector diagram for this. This is important. Let's draw the vector diagram for this. Let's go for vector diagram. This is a alternator vector diagram. I am going to draw the vector diagram for alternator. Alternator nothing but generator. In a generator, whenever a rotating conductor placed in a magnetic field, nothing but we should have a magnetic field. For example, this is my magnetic field, main field flux. Whenever a rotating conductor placed in a magnetic field, whenever a rotating conductor placed in a magnetic field, then it produces EMF. What is the angle between EMF and the flux? That is the 90 degrees. The EMF and flux displaced by 90 degrees. And for example, this is the voltage V. This is the voltage V. And for example, I am taking lagging load. This is the armature current which is lagging to the voltage, The angle between voltage and the current is nothing but power factor angle phi. The angle between induced EMF and the voltage, EMF and the voltage, is nothing but load voltage delta. What is that? Load angle. Load angle represents with delta. Power factor angle represents with phi. And the angle between EMF and current, armature current, is represents with psi. Psi is nothing but internal angle. Internal angle represents with psi. Here the load angle is the angle between EMF and the voltage, and power factor angle is the angle between voltage and current. Internal angle is the angle between EMF and current. From this, the angle between EMF and current is nothing but psi, right? So what is the relation between these three? Here, psi is equals to delta plus phi, where plus for lagging, load. For example, it is leading load. When it is leading load, the armature current is here. When it is leading load, actually this is EMF and this is V. If it is leading load, this is my armature current. Now tell me, where is my psi? The psi is nothing but this one. And the angle between voltage and the current is phi, and this angle is delta. Because the angle between voltage and EMF is delta. Now psi is equals to delta minus phi, where minus represents a leading load. Minus represents the leading load, plus represents lagging load. This is very important question. This is for leading load. For leading load, psi is equals to delta minus phi. For lagging load, psi is equals to delta plus phi. Delta plus phi and delta minus phi. Is it okay? Right. Let's see. Now we have three types of voltage drops here. One is the resistive drop. Always the resistive drop in parallel to the current. So actually the current is here, so the resistive drop also here. This is what IARA, drop due to resistance. And next one, drop due to reactance. that is perpendicular to this one. So this is drop due to reactance, which is called IAXL. And again we have another reactance drop, that is drop due to armature reactance. Drop due to armature reactance is there. So drop due to armature reactance is like this. This is drop due to armature reactance, IAXA. IAXA, and this is our EMFE, because E is equals to V plus IARA plus or minus, or simply we are taking plus because of it is lagging load, plus J into IAXL plus J into IAXA. This combinedly is also known as IAXS. You know that already. This combinedly also known as IAXS. Yes or no? Yes or no? So now tell me, this IRA plus IAXS, is nothing but IAZS. This is nothing but IAZS. And here, if you take the line like this, what is this line? This line is equals to V plus, this is V plus IARA plus JIAXL. This is called air gap EMF. This is called air gap EMF, EAR. Air gap EMF is nothing but V plus IARA plus JIAXL. This is the vector diagram for our synchronous machine for lagging load. And here finally, from the analysis of this vector diagram, if you calculate here from this vector diagram, if you calculate EMF E, this EMF E is equals to, from this analysis, vector diagram analysis, EMF E is equals to V cos pi plus IARA whole square plus V sin phi plus or minus IAXS whole square. V cos pi plus IARA whole square plus V sin phi plus or minus IAXS whole square. Here plus for lagging load again, minus for leading load again. At unity power factor nothing but cos pi is equals to 1, sin phi is equals to 0. If you substitute at unity power factor, E is equals to, tell me, E is equals to V cos pi. What is cos pi? Cos pi 1. So V plus IARA whole square plus sin phi 0. So IAXS whole square. This is for unity power factor. These are the EMF equation. Up to now clear? Yes or no? Clear or not? So what is that? Here the first thing, xi is equal to delta plus or minus phi, and another thing air gap EMF and EMF, and another thing EMF equation from the vector diagram analysis I given you directly. This is important. So from this, plus for lagging, minus for leading, for unity power factor also, you know that. Then next, for example, they will ask you question, what is the angle between main field flux and armature flux? Or what is the angle between armature axis and field axis? They will ask you question like that. Can you tell me what is the angle between the main field winding, main field flux and armature flux. This is the main field flux. And where is my armature flux? Generally, my armature flux is along the armature current. If we calculate the if you calculate the resultant flux or air gap flux, the sum of these two is called air gap flux. So see here how from the trapezoidal analysis, so this is the air gap flux. Here actually the EMF and main field flux displaced by 90 degrees, and air gap EMF and air gap flux also displaced by 90 degrees. These two are also displaced by 90 degrees. Actually EMF and main field flux displaced by 90 degrees, and air gap EMF and air gap flux also displaced by 90 degrees. But I asked what is the angle between main field flux and armature flux. Can you tell me? Actually, we want the angle from this armature flux to the main field flux. From here to here. This is 90 degrees and this is psi. So the answer is 90 plus psi. For our alternator, this is for alternator. For our alternator, the angle between main field flux and the armature flux is 90 plus xi. 90 plus xi. This is also very important question. Here we have two formulas. One is the psi and another one is the angle between armature axis and flux axis. So this is the also, and then after the EMF equation is very important for our examination. They will ask you question on this EMF equation indirectly. Even in voltage regulation also we need this EMF equation, right? So finally I draw the vector diagram for alternator, and here the final conclusion is voltage drops are mainly due to three types. One is the resistive drop, leakage reactance drop, armature reactance drop. But here the maximum drop due to armature reaction or armature reactance. Let's go for armature reaction in the next video, right? Thank you.